In episode 10, deployments kept a set number of pods running and rolled out updates without downtime. This episode covers a problem that creates immediately. If pods can be replaced, scaled, and rescheduled at any moment, how does anything else reliably find them? Every pod gets its own IP address, but that address is not stable. Delete a pod and a deployment replaces it, exactly like episode 10 showed, and the replacement gets a brand new IP. Scale from 3 replicas to 5, and you've got 2 more IPs that didn't exist a second ago. Hard-coding a pod's IP anywhere is broken by design. A service solves this by giving a stable virtual IP address and a DNS name that sits in front of a group of pods and automatically load balances traffic across whichever ones currently exist. It never talks to pods by their individual IPs. It uses the exact same label selector mechanism from episode 10's deployment to figure out, continuously, which pods currently qualify. Here's a service in YAML. A selector matching the same labels as your deployment's pods, and a port mapping. The port the service listens on, and the port it forwards to on each matching pod. That's the whole object. kubectl apply-f service.yaml creates it. kubectl gets services shows its virtual IP, sometimes called the cluster IP, alongside the port you configured. From this moment on, any other pod in the cluster can reach your application through that stable address. Or better, through its DNS name, which Kubernetes assigns automatically, service_name.namespace, svc.cluster.local, or usually just the service name for short. That's the exact same name-based convenience Docker Compose gave you back in episode 7, now working across an entire cluster instead of one machine. There are 3 service types worth knowing, and they answer different questions about who's allowed to reach it. Cluster IP, the default, is only reachable from inside the cluster, the right choice for a database or an internal API that nothing external should touch directly. Node port opens a specific port on every worker node's own IP, reachable from outside the cluster, functional, but clunky for production. Load balancer asks your cloud provider to provision a real external load balancer that routes in from the internet, the standard way to expose something publicly when you're actually running on a cloud platform. Let's watch it work. Curl the service's name from inside another pod in the cluster, run it several times in a row, and the response comes back from a different backing pod each time. That's the built-in load balancing happening automatically, with nothing extra configured. Let's recap. Pod IPs are unstable by nature. A service gives you one stable address and DNS name in front of however many pods currently match its selector and load balances across them. And cluster IP, node port, and load balancer answer the question of who's allowed to reach it. Internal cluster traffic, external node access, or a real internet-facing endpoint. We've been passing plain values inside our YAML this whole time. In episode 12, we cover config maps, secrets, and how Kubernetes handles persistent storage, the equivalent of episode 5's volumes, at cluster scale. Subscribe so you don't miss it. See you then.